In this video, we're going to be using Newton's method, which is an iterative process using the derivative and specifically the tangent line to find the roots of a function. All right, so the problem that we're looking at is f of x equals x cubed minus 4x squared plus 1, and we want to find the roots of this equation. And if you remember back to pre-calculus, we could find the roots of an equation by doing things like factoring an equation or by using the quadratic formula. And in this case, we cannot factor this equation and we cannot use the quadratic formula, so we're going to have to try another approach. And that's what this does for us, Newton's method. And so the first thing is we have to remember back to how many roots we might have. So we would probably have up to three, not probably, we will have up to 3 roots because this is a cubic equation. And we're just going to solve for one of them right now. So you could do this process for the others as well. But to begin with, we need an initial guess. And so I'm going to look first at what happens if I plug 0 into the equation. If I plug 0 into the equation, I get 0 cubed minus 4 times 0 squared plus 1, and that equals 1. Okay? And let's go ahead and see what happens when I plug 1 into the equation. If I plug 1 into the equation, I get 1 cubed minus 4 times 1 squared plus 1, and that is 1 cubed is just 1, and then minus 4 is minus 3, plus 1 is minus 2. So notice that I am positive here at 0, and then I'm negative here at 1. What does that mean for the equation? Well, if something goes from positive to negative, it must pass through 0, right? And so that means that I'm going to have a root somewhere between 0 and 1. And so we can start with a guess. And so what do you think a logical guess would be? You could choose anything, but I think I'm going to choose 1/2. So my initial guess, x naught, is going to be 1/2. All right? We can call this x sub 0 or x naught. And I call that, and I'm guessing that it's 1/2. And then all I do is I use that to calculate my further guesses until they become super close, and then you can see that they're converging to one number. All right, so to take that, to use these calculations, we're going to need f prime of x, because you can see within the formula we have f of x naught over f prime of x naught. So I'm going to go ahead and move up here, and I'm going to take the derivative of this. It's just we have it handy, and that is 3x squared minus 8x, right? And so x sub 1 would equal 1/2 minus f of 1/2, and that would be 1/2 cubed minus 4 times 1/2 squared plus 1 all over f prime of 1/2. And so that would be 3 times 1/2 squared minus 8 times 1/2. And this is the most complex part of it because you have to make sure that you calculate this correctly. And so when I calculate it, I get the answer 0.53846,154. And that is going to be my second guess. So the next one is going to be x sub 2 equals, and you plug that value in wherever there's an x. So it'll be 0.53846,154 minus, and you do the same for each place, 0.53846,154 cubed minus 4 times 0.53846,154 squared plus 1. And then this part right here is over 3 times 0.53846,154 squared minus 8 times 0.53846,154. All right, and you calculate that again, and you're going to get x sub 2, and then you use that to calculate x sub 3. And you'll do that continuously until you reach the required number of decimal places where your answers match up. Now, as you can see, this can become quite tedious. So some people have the ability to put this into their calculator. And you can do that by putting y equals, and again, it's your first guess, which is x, minus, and then we have f of x, which is x cubed minus 4x squared plus 1. And then that's over f prime of x, so 3x squared minus 8x. All right, and then you put that in your calculator, and then you can, calculate with your first guess, and then you take that and you plug it in as your x for the second guess, and so on. So I did this with a Desmos calculator, and I just want to share with you what that looks like. So as you can see, I've taken this equation right here and I've plugged it into my calculator. And various calculators will allow you to do that in different ways. But I plugged that in, and then I made my initial guess of 1/2. And when I made my initial guess of 1/2, I got the 0.538466154. I then took that and moved it down as my second guess, and I entered it manually, and I got my second answer, which is a little different, as you can see. And then I took that answer and I moved it down here, plugged it in as my third guess, and you could see that this time it didn't change quite as much, but it changed a little bit. And then when I plugged that one in for my guess, my final guess was identical to the last one. So that's what will happen, is they will start getting closer and closer until you realize that this is your approximation. Or not your approximation, but this is the answer. And so you may be wondering why we don't just use the trace function on the calculator to trace the function and trace this function and find out what its roots are. And that's a valid point. We have the technology these days to do that. But back in the old days, when they didn't have the technology, this was the way they could do it. And so I want to reiterate what this process is doing. What we have here is a curve, and it crosses at this red dot right here. And we're trying to find that place, and that's called a zero, right? Or a root. And so we make an initial guess of x naught, and we first test that x naught in the function to see if we have a zero at that point. And if not, we draw a tangent line to the curve at that point, and that's the blue line that we have here. And then we see where that blue line crosses the x-axis, and that's x sub 1, and then we use that to draw another tangent line, which is the green tangent line. And then the green tangent line, we see where that crosses the x-axis, and that's right here at x sub 2. And you can see that these values get closer and closer to the red dot or the root.